In this video, we are going to look at question 49 from the specimen paper.
So in this question, we are supposed to say how many triangles there are with lengths of sides which are integers and whose perimeter is 12 units. And I will say, without loss of generality, that A is bigger or equal to B and to C. So no other side is longer than A. I don't want to say that A is the longest because, strictly speaking, there could be some could be equal, but B and C simply can't be bigger than A. That's one assumption, and what it means for us is that the minimum value A can take is 4, in which case C plus B will be 8. Just imagine that A would be 3, then C plus B would be 9, to give the perimeter 12, and when two integers add up to 9, then one of them has to be bigger than 3, and that would violate our this assumption which we set out. And another useful fact which we can utilize is that for the triangle to exist, the sum of the lengths of the shorter two sides has to be bigger than the length of the longest of them. That's what's called the triangle inequality. And it's very easy to imagine that if C and B weren't together longer than A, then they wouldn't even reach to meet at a point. So without this condition, the triangle wouldn't even exist. And that in turn tells us that the maximum value A can take is 5, in which case C plus B must be 7 to give 12. If A was bigger by just 1, if A was 6, then C plus B would be 6, and C plus B, 6, is not greater than 6. We wouldn't get a triangle but a line, and so we have found that A is an integer between 4 and 5. Well, that means that it is 4 or 5. So can you think what the possible lengths of the three sides are when A equals 4? Well, the only possibility is that they all equal 4, because if just one of these was smaller or bigger, then they would be in contradiction with our assumption that A is the greatest. B or C would have to be 5 or more. For A equals 5, however, we'll get two options. So either B is 5 and C is 2. B can be more than 5, that's the maximum value it can take. But it can be less, it can be 4, in which case C has to be 3. And again, if B was now 3, then C would be 4. And that's the exact same triangle as this one, except with the sides labeled differently. So to conclude, there are 3 unique, by which I mean non-congruent triangles, which satisfy all of the conditions above. And so C was the correct answer.